Greetings, mathematicians, and welcome to Comparing Bits and Pieces, our new unit. As you can probably assume, we're going to be comparing bits and pieces. Okay, I'm sorry. Anyway, today's lesson is all about ratios. Please take a moment, copy down the focus question, please. What are ratios and how do we write them? Please notice that I left some space in between the focus question and these drawings. That's because I want to include the definition for what a ratio is here. So actually, go ahead and throw this in there. We're going to define what a ratio is, and then draw those pictures for me to the best of your ability. So we're going to define the word ratio. Let's first talk about what a ratio does. Well, a ratio compares values. We could also say quantities, amounts of things, right? So it compares values or quantities. In other words, we could also say a ratio says how much of one thing there is compared to another thing. Let's write that down. How much of one thing compared to another thing. And we're going to take a look at some examples. To get us started thinking about ratios, we have these things called for every statements. So I want you to take a look at this drawing that I have here. Okay, you're probably already thinking some things that you might see show up on our notes here. Okay, so here's an example. Here's a for every statement. For every, go ahead and write this down. For every 4 hearts, comma, there are 2 stars. For every 4 hearts, there are 2 stars. That is what we call a for every statement. You might be able to write a few on your own. See if you can write 1 or 2 more for every statements. Here's another for every statement that I wrote down. For every 3 circles, there are 4 hearts. Okay, I want you to write 1 more, please. We're going to write a total of 3. Yours could be very different from mine, and that's okay, so long as the statement is true. All right? So let's write 1 more. Pause the video, write 1 more. All right, and here's my last one. For every 2 stars, there are 3 circles. Now, obviously, there are more than 3 statements we could write. However, I think this is a good starting place. And like I said before, this is going to start our thinking about how we write ratios. Okay, write this down, please. When we write ratios, the order matters. Write it down. Put it in a box. Underline it. Highlight it. Put stars around it. Make it stand out. This is something very important to remember about ratios. The order in which you write the numbers is very important. Let's take a look at some examples. All right, here's our first example. Go ahead, pause the video, copy this down. The directions tell us to write the ratio of hearts to stars. Pay very close attention to that order, please. Write the ratio of hearts to stars. Well, if we look at our drawing, how many hearts do we have? We have 4 hearts. So that number must go first. Right? Then we're going to write the word 2. And then how many stars do we have? Well, we have 2 stars. So we say the ratio of hearts to stars is 4 to 2. This is one way to write a ratio. However, we have a total of 3 ways to write ratios. Take a look. I'm going to rewrite this ratio in another way. I'm going to put a comma there. Another way you could write this, it actually looks like a fraction. So remember, the ratio is hearts to stars. So we write the ratio 4/2. However, I read this the same way, 4:2. So there we have two ways to write a ratio. There is one final way to write a ratio, and this is using something we call a colon, not the end of your digestive tract, but you know, the symbol colon. It looks like this. I read it the same exact way, 4:2. So, when we're writing ratios, what matters? The order matters. The order matters, folks. These ratios represent the hearts, the number of hearts to the number of stars. Let's try another example. Here we go. Here's our second example. Write the ratio of stars to circles. Go ahead, pause the video, see if you can write down the 3 ways to write this ratio. All right, here's what I got. Okay, we're going to take a look at another example. Just kidding. Before we move on to the next example, what's wrong with my work here? Did you catch it? Did you catch it? Take a look at the numbers that I wrote. I wrote 3:2, 3:2, 3:2. The question asked me to write the ratio of stars to circles. Is this correct? Let me take a look. How many stars? There's 2 stars and 3 circles. But they want us to write the ratio of stars to circles. Mr. RG wrote this backwards. So, I'm going to keep this on here, but this would not be correct here. Instead, we'll say that this is the ratio of circles to stars. Like I said, folks, the order in which you write the numbers matters. So instead, what you should have written is something like this. 2:3, 2:3, and 2:3. These are the correct ratios for the number of stars to the number of circles. Okay? Again, the order in which we write ratios matters. Okay, I'm running out of space on my first page here, so I'm gonna go ahead and flip the page and work on the back here. Let's go ahead and write this down. Ratios can be scaled up and scaled down. What this means is we can change ratios so that way they look bigger or they look smaller. So let's write that down. I'm gonna add this underneath scaled up. In other words, we're making this bigger. So we made the ratio bigger. If we scale down a ratio, we've made it smaller. Let's take a look at some examples. Let's say I have this ratio here of 4:5. This could be really anything. It could be 4 cats to 5 dogs, 4 carrots to 5 stalks of celery, whatever you want here. But let's say I want to scale this up. Let's say that I want to double the amount of things that I'm comparing. When you scale up a ratio, what we are doing is we're actually multiplying each number by the same number. So like I said, if I want to scale this up by 2, I'm going to multiply each number in my ratio by 2. And let's see what happens. I know that 4 times 2 gives me 8. And I know that 5 times 2 gives me 10. So my new ratio, now scaled up or made bigger, is 8:10. Now, I want you to take a moment and look at this original ratio and our new ratio. if we were in class, I would ask, what do you notice? What do you notice about these? Or what if I were to write them as fractions? I'm going to write them next to each other. So here I have my ratio of 4 to 5, and I just changed it. I just changed it to 8 to 10. What do you notice about these two fractions? I hope you're thinking that these two fractions are what we call equivalent. That's right. These are equivalent fractions. I'm going to write that down. These are equivalent fractions, or they're fractions that mean the same amount. They just look different, right? So I'll call them equivalent fractions, but in parentheses, we're also calling them ratios. So these are equal to each other. They mean the same exact thing, they just look different. And that's what happens when we scale ratios up or we scale ratios down. Let's take a look at when we scale a ratio down. All right, take a look at this next example. So I started with this ratio of 10 to 5, and I scaled it down. I made it appear smaller, or at least the numbers got smaller. My new ratio is now 2 to 1. I want you to think about what could I have done to both numbers in order to get to 10 and 5. What could I have done to 10 and 5 to change them into 2 and 1? Think about that for a second. Well, if we take a look at what we did for problem number 1, we scaled up, right? We multiplied both numbers by 2 to make the numbers bigger. This time we're scaling down. Are you having epiphanies yet? When we scale down, what are we doing to each number? We're not multiplying now, but we are dividing by the same number. So let's take a look at what I divided by. How do I get to 2 from 10 by division? Oh, I could divide this side by 5, and then I should also divide. Hey, does that work? Yes, it does. So to scale down my ratio of 10 to 5, I divided each number by 5. And let's take a look at these fractions here. Let me rewrite them as fractions. I have 10 over 5, and I have 2 over 1. And to go from one to the other, right, I just divide the numerator by 5 and the denominator by 5. I've created my equivalent fractions, okay? So again, ratios can be scaled up or made to look bigger, or they can be scaled down, made to look smaller. And the operations that we use to do this for scaling up is multiplication, for scaling down is division. All right, new section here, folks. Last section of our notes today. We're going to be talking about different types of ratios. Okay, so let's look at an example here. Go ahead and write this down. I have 3 oranges, I have 4 strawberries, and I have 2 kiwis. The first type of ratio that we've actually been talking about this whole time is what we call a part to part ratio. So for example, I could write the ratio of oranges to strawberries. I have 3 oranges to 4 strawberries. I could also write 2 kiwi to 3 oranges. And then let's do one more. I could do 4 strawberries to 2 kiwi. Oops. Gotta stay color-coded here. These ratios over here on the left side are what we call part-to-part ratios. That's because each of these numbers represents a part of something bigger, right? Let's take a look at some the other type of ratio. Getting ahead of myself here. Let's take a look at the other type of ratio, and then we'll make some comparisons here. The other type of ratio we can write is what we call a part-to-whole ratio. This type of ratio usually involves the total amount of things, right? In this case, well, what are we comparing? There's oranges, strawberries, and kiwi. It looks like we're comparing fruit. Well, how many total fruit are there? So if I add 3 plus 4 plus 2, so that's 7 plus 2, there's 9 total fruit. Now take a look at the ratios I'm about to write. I could write 3 oranges to 9 fruit. I could write 4 strawberries to 9 fruit. And let's write one more. I can write 2 kiwi to 9 fruit. What do you notice? Well, all of these part-to-whole ratios have the total amount of fruit. So this makes sense. We're comparing a part of the total to the actual total, right? We took this part of oranges and compared it to the total number of fruit. We did the same thing with the strawberries. We took the part of strawberries and compared it to the whole number of fruit. Okay, that's why we call them part-to-whole ratios, because we're comparing a part to the entire thing, the whole thing. Now let's revisit what a part-to-part ratio is. Oh, well, a part-to-part ratio is just a comparison between two different parts of the whole, right? So in this case, I'm comparing the part of oranges to the part of strawberries. Or I'm comparing the part of kiwi to the part of oranges. Or I'm comparing the part of strawberries to the kiwis. Okay? So those are the two different types of ratios you will see as you progress through 6th, 7th, 8th grade math, and even further. Alrighty? So that concludes our lesson on ratios today. Thank you for your hard work. If you have questions, please let me know, and I will see you all in the next lesson.